So I want to say good morning, good afternoon, and good evening to everybody. My name is Christina Baxter, and I'm the CEO of Emergency Response Tips. And I partner with Proengin to do this series of webinars for you. And so I will throw it over to Scott and let him introduce himself, and then we'll turn off our cameras and get into the meat of the business.
Yes, I'm sure you'd rather not see us. You'd just rather
Exactly.
hear us. This is probably a little bit better. But yeah, welcome everyone. Some people it's evening, some people it's afternoon, but we appreciate this. So really, this is just another of a series of webinars that we're doing as educational to the marketplace. And really, the purpose of this is to kind of to cover a variety of different topics and pertinent topics. The specific topic today is on overall critical infrastructure and using protection methodologies on how to handle that, as well as some of the morphing threats that we're seeing out in the world that we're facing, which is constantly changing. So hopefully this will be beneficial to you, and we look forward to the discussions. And as always, if you have questions as we're going through there, you can write those down and we will address those. Or if you have ones you want to raise, we can do that afterwards. But that's what we're here for, is the educational aspect of it. So make sure if we don't make sense, let us know.
Okay, and as Scott and I noticed when we set this up this morning, there's an interface change on the GoToWebinar. So if you're not used to this, the questions area where we usually put all the questions is in the top right. It looks like it's 4 spaces over from the far right of the corner of the screen. And so if you want to put in questions as we go, we'll try to address some of those towards the end of the webinar if there's extra time. The other thing to keep in mind is that we do record all of these webinars. And so it is being recorded. So if you want to come back and see this and get more information, or if there's other colleagues that you want to send to it, we will have it up on the Proengin YouTube channel. And Naomi does that for us, usually a couple days later, because she does the translation and everything on there as well. So she does a lot of work to make it pretty, because Scott and I, we all do that. So with that, cameras off, and we will get started. Okay, so as we said, we're going to discuss critical infrastructure protection. But one of the things that I'm really excited about today is a new product to the Proengin line, which is called the Proengin SHIELD. And we'll talk about that quite a bit as we go throughout today. But I think you'll see why it's so important to us, because it kind of pulls everything back together. Not only does it provide us that common operating picture, but it also links all of our detectors together and allows us a space that we can put decision support and things of that nature right embedded within all of our sensing systems. So I'm going to show you kind of where we go with there. So we're going to start off with a little bit of a CBRN threat update. The reason behind this is that there has been an awful lot of change in the beginning of this year. And there's a lot of things coming up around the world that we need to be really cognizant of what the terrorist literature is putting us towards and what they're talking about. Then I want to talk a little bit about some past detection integration challenges and why we're so interested in finding new things that will work for building protection, as well as for integrating sensors in an outdoor ecosystem. And then we'll talk a little bit more about government building protection, understanding biotrigger systems and what they mean, as well as the fixed site biological monitoring. And so I think many of you have seen this slide before, but this is how I try to present an overview of where we are on the current threat index. And one of the things that I want you to really focus in on is that it's no one thing. We are in the middle of a revolution of the threats, and those threats come everywhere from chemical to biological to radiological to incendiary and explosives. We are never being presented with one thing. And in fact, most of what we're seeing today is a combination of effects. And so we have to start thinking about how are we going to take all of the sensing systems that we have available to us and make them work together to provide us an overview picture of the entire scene. So as we talk about some of the ones that hopefully everybody's pretty familiar with right now on that urgent priority, those are the things that are happening right now. And so the binary devices, the chemical threats where you have 2 seemingly disparate things. So generally a solid salt, and then a liquid that's generally an acid. And we put those things together and they produce a gas. So things like hydrogen cyanide generators, hydrogen sulfide, phosphine, and chlorine. Those are the main binary devices that we're seeing right now. Corrosive attacks with just people throwing materials at one another. It's disturbing. Scott, I think you're still on. If you can go on mute. So corrosive attacks where we have people throwing things at each other. And that's very disturbing. That has everything ranging from domestic disputes to stranger-initiated attacks. Irritants, where we may have a something like a pepper spray. This happens every day in the United States. I don't know about other parts of the world, but we do see those pepper sprays deployed on subways and different internal areas where they make a bit of a difference. Pharmaceutical-based agents, so those fentanyl-related substances, those chemicals that are readily available across the United States especially, but we're seeing more of that proliferating across Europe right now as well. And so those types of materials that are opioid in nature. The toxins have really changed a lot, and we'll get into a little bit about why that is. But the ones that we're really focusing in on the most right now are ricin, abrin, the standard two from yesteryear, nicotine, extracted and purified, as well as botulinum making a comeback in some of the literature. The Molotov cocktails and incendiary devices have really switched over towards those that are napalm-like, adding in the styrofoam or other materials to make them stick and burn hotter and longer. And then the homemade explosives, the chlorates, the perchlorates, and TATP coming back again. In terms of the near term, those things that we should be ready for happening in this year, but hopefully not today. Toxic industrial chemicals, all different types of pesticides. Trying to get around the use of chemical warfare agents, the traditional agents, by grabbing pesticides that have similar characteristics and using them offensively. They won't get as much lethality, but they still will get lethality, and it's easier to get their access hands on. Sulfur mustard, easy to make, easy to employ. A-series agents. Now, one of the things to think about with all three of those is that all three of those, the threat is not a solid liquid gas threat. The threat is actually an aerosol threat. So it is generally, for these ones, liquid droplets that are being dispersed as an aerosol, so they'll move like a gas. But if you have filters on your instrumentation, it's going to pull them right out, and you're going to miss those altogether. Radiological, we're seeing a lot of missing sources right now, and it does make you worry a bit. The cesium, the cobalt, iridium things are adding up. Explosives and incendiary, the fireworks and metal enhancements. Almost all the explosives that have been found early this year have had metal enhancements of some sort, especially in the US. The prepare, where are we going? Where are the things that they're talking about that they're trying to perfect? So obviously, chemical warfare agents of sarin, the VX, they talk about those, but reality is the precursors are very hard for them to get. The toxins, switching over to saxitoxin, tetrodotoxin, paleotoxin, those things that are discussed but not really readily available, but are becoming more so. Traditional biological warfare agents, the anthrax, those types of things. But what's coming along and coming along pretty quickly, which changes the whole look of what we do, are those genetically modified agents. And that is hopefully no more than a year, hopefully more than a year or two out. But as they start getting there, we do have that problem. This brings us to a critical gap in what we do, because most of our systems that we deal with today are library-based. And as we get towards these genetically modified agents and we start to make more agents that are slightly different, the more we rely upon library-based systems to identify, we get stuck in this loop where we can't identify it until it's already happened. We've got to go backwards. And that puts us into a lack of preparedness. And so we've got to start thinking about what are we going to do there. And then, of course, nuclear threats and then industrial and military explosives. Those continue to be a threat. They're never going to go away. But they go and come and go in terms of the depth of the threat. So that's kind of where we are today. But two things I wanted to bring up to you that came out in the early parts of this year. So the first was a new magazine called Invade magazine. It was issued in February of 2026, and it came out of Pakistan. And what this did is almost like the old Inspire magazines, but it was very much about getting people that were already likely over that jihadi step, but trying to get them to change their idea about what types of materials they would use. And so in this case, they said, get away from some of these explosives and things, or the devices that will get caught by the different security methods, and start focusing in on those biological threats or chemical threats that they're not looking at, the binary devices, the biological toxins. And so they did provide very detailed recipes for the production and dissemination of botulinum and oleander in terms of toxins. And unfortunately, those were pretty well done by them. The chemical toxins, the cyanides, very poorly done by them. So I'm happy to say that keep following that all day and you're not going to get the threat that you're trying to get. So with that said, we do have a problem. We have a problem where they are focusing towards different toxins and things that are 100% meant to get around the technologies and screening tools that we currently have in place. And so if we're looking at botulinum and these types of things as spread threats, we need to make sure we have the way to detect these. Now, will we be able to identify them in real time? No, today we don't have those technologies that are available to do that in real time. But can we identify that there is a threat there? Absolutely. Now we have to start thinking about the dissemination methods that they're talking about. Very different ways of disseminating and different ways of placement. And so as you're out there and working with people, we've got to start thinking about that. They did expand out the targets. So definitely looking at large crowds, a little bit of getting away from those targets that are all rich people and getting into targets that are going to provide the biggest psychological impact. And so areas where you have large crowds, areas where you have people forming lines, that's what they're looking at right now. And then they follow this up with an Inspire guide that came out in March of 2026. Now remember, we had not had an Inspire guide since 2010, an Inspire magazine since 2017. But in 2024, we had the Inspire video series, which very much focused on the use of inorganic explosives to get around the detection systems. And in 2025, we had updates to Inspire guides that came out 9 and 10. Those were very focused on getting away from the original targets of very high profile people and focusing into a broader soft target type of thing. And what we're seeing in this Inspire guide that came out in March of this year is a big shift towards psychological impact away from that economic impact. So no longer focusing on the critical infrastructure that had a financial nexus, but now looking at total critical infrastructure, and a lot of that being transportation networks and anything focusing on energy. In terms of the soft targets, very much focusing on high density public spaces, understanding that people in lines make easy targets, and that to get the maximum psychological effect that they're looking for at this point, it's the civilian population. If you remember back to the earlier days, they said, go for the rich people because rich people make the news and stay in the news. But now what they're doing is going towards large volumes of people because large volumes of people also make the news and stay in the news. So those are some of the things that have changed. And as we go towards the upcoming events around the summertime sessions in the Northern Hemisphere, there's a lot going on right now. I just want you to keep in mind an open objective on what things are coming. It's not all the same as our original pressure cooker bombs and things of that nature. Things have changed a lot, and we need to open our eyes to the things that they're talking about and what they're planning to do. Because remember, it's all about what their plans are today. We have no idea who they are. Most of them are the boy next door or the kid next door. What we do know is the things that they're going to try to do. So we need to counter that. So the first thing I wanted to talk about after the threat was, what are those challenges that we've seen in some of the past programs that are out there? So one of the ones, and I pulled a lot of this from the Government Accountability Office reports on the old BioWatch program. But just looking at the BioWatch program that we've had in place in the United States for many years, and it's been shut down right now. But a couple of the things that really jumped out at those, part of that was the time lag, in that you had to go out and just randomly take samples and hope that you caught something. Then when you got false positives that were environmental noise, but then created quite a problem. So the frequent false positives there kind of made it so people weren't trusting it anymore. And the biggest problem there was having no urban baseline, having nothing to say, what does environmental noise look like? And how does that noise change diurnally? How does it change? What's the time profile? What's the humidity profile? And how do all of those things work? The sensitivity and the technical uncertainty were way off there. The last generation did not work well and got canceled in 2014. But a lot of this came down to not having the actionable intelligence to be able to do something when you needed to. So what we're going to really focus on the most is these ones that I have circled here. How can we quickly know when something is coming above background and maybe then trigger a sample to be taken instead of randomly taking samples? How do we collect background data that's continuously collected and creating a background matrix that allows us to get around that problem? How do we do all of that, but still focus on that low concentration threat? Because if we don't catch it at the low concentration, it's going to be too late. And then all while taking forensic evidence to make sure that we have a sample that is usable for law enforcement and public health to go further down that pathway. So the other thing that we brought up was the problems that we're having with the library-based technologies. So as we start going down this pathway, and we saw this really in detail with the fentanyl on the chemical side, where as each of the different fentanyl materials was being targeted and caught, they just modified the attachments to that chemical to make another one. And so to get around legalities, to get around different things, they modify the chemical slightly, gets it around a lot of the detection technologies, but also gets it to a point where it's getting around a lot of the legal problems. That forced DEA and others around the world to start going to a structure-based threat profile for chemical threats. Now, the problem we have today is the biological threats are the exact same problem. As we get into genetic engineering, we don't know what the next threat's going to be because it hasn't been made yet. And so instead of always looking back retrospectively and trying to build a library after the threat has already hit, knowing that they're going to modify that and make the next threat, we've got to start getting ahead of that. And how do we get ahead of that? To get ahead of it, we got to start looking at some of these agnostic detection technologies. Now, we've been following next generation sequencing for years, and it's coming along, thankfully. The problem that we have with employing next generation sequencing in critical infrastructure is that the data that we require to be able to go back and rebuild these systems does require a heavy load. To get even a near neighbor match, we're talking a day. To get a full genomic sequence and try to identify a new threat, we're talking multiple days. Unfortunately, that's not fast enough today. And frankly, we're having to use very high speed, high throughput data sets to go back to laboratories where they can do the bioinformatics to match up those sequences. There's some MALDI time of flight, matrix assisted laser desorption, ionization, time of flight mass spectrometry coming along. It is extremely expensive, but very specific. And so this has some great potential for the future to be able to measure down to very small amounts. Again, very expensive and large systems to be able to put in place in terms of building protection, but something to watch for in the future. So where we are today is really with flame spectrophotometry, which allows us to see that there is the threat of that nature there, but doesn't tell us what it is. We're still going to be waiting for those MALDI-TOFs and those next-gen sequencing to come along and be able to tell us what it is. But at least this will allow us to say something is there that shouldn't be, and it's well above the background. And so that's the kind of thing that we're looking at today. So we're trying to figure out how can we quickly identify that there's something there that has characteristics of a threat material, but doesn't meet the current materials that we have. And so that's the kind of thing we're looking at. The other thing we have to look at is the response time. And I said that a little bit on the genomics. The issue that we have with the genomics right now is it's got so much promise and it's getting there. And frankly, one of the systems that's coming along, I've been looking at for about 15 years now, and it's coming along very well. But when you start looking at that, you're really talking about a material that is going to take us a retrospective look hours to days. And that's not fast enough for us to get that detect to warn and detect to protect in place. And so we are going to have something in between that says, take the sample, start to do the protection, and then we can come back and figure out what we're going to do as we get more information. And so that's where we are today in terms of response times as it relates to this. So today, the biggest challenges that I've seen in all the reports and then talking to some of the different system operators are that we have disparate detection systems, understanding what the data from each of those means, especially when it's put together. Slow response times. By the time we get the response or the recognition of something, it's either too high of a concentration and we probably have people exhibiting symptoms, or the threat has already passed us and is now on to another place. And if we don't have a series of sensors in place, we don't know where it moved to. False positives. Environmental noise causing false positives. When we talk about critical infrastructure, we're talking about temperature and humidity changes. We're talking about high levels of background with dust and pollen and other things, depending upon whether we're inside or outside. And all of that starts to create this matrix of things that we have to get around. The limited background data, letting these things run, making sure that you have machine learning or even AI-enabled algorithms that allow you to get a smarter and smarter system as it captures more and more data. Getting around library-based systems, which are going to be used in the laboratory-based response. But when we're talking about that first collection to get the sample to the library, we've got to figure out what we're going to do to get ahead of the problem. And then, of course, as I said before, the data interpretation. When we start using disparate detection systems, we've got to stop and think, what do these things tell us together? Especially if we're talking about non-library based systems. So we have things that may have cross sensitivities, but how do we make them work for us? And so that's kind of the key to what we're looking at to try to build the next generation of infrastructure protection systems. I'm going to turn it over to Scott for a moment and have him start talking about government building protection while I get some Diet Coke.
Thanks, Christina.
Over to you.
Yeah, so you want to click the next slide, please? So what we see here is kind of in the beginning slide of pulling together all of the threat profiles that we talked about. Christina did a great job of talking with today. And it is a pretty complex architecture that we're dealing with presently, with a large number of changing types of threats associated with that, as well as the potential use of biologics and chemicals and biological toxins. And especially now with AI coming, the ability to synthesize or create new versions or variants of materials with it. And one of the challenges of those materials is you're only as good as what is in your library associated with that. So if you change an atom, in many cases, certain technologies won't see it anymore, even though it behaves with that. And with some of these new tools that exist, we have the ability to synthesize those or to determine that they could be synthesized a lot easier than they were in the past. So holistically, there's a large change in there. And additionally, what we're seeing is a lot, especially with now fourth generation chemical warfare agents and other types of materials. If you weaponize fentanyl, for example, that occurred in Moscow in the theater when the Chechen rebels did that, they introduced that through the HVAC system and they aerosolized it. Aerosol threats are becoming much more prevalent, and some detection systems struggle with that. One advantage of flame spectroscopy as a tool is that it's not subject to those. We don't have any filters ahead of that. So those aerosols are able to be detected versus some detection technologies. They have a pre-filter and that filter filters them out, or it can cause issues with the ability to see it. So one of the things when you're talking about overall critical infrastructure protection that becomes a challenge for us is how do we handle this disparaged versions of variety of different materials, and how do we handle the ability to do both chemical and biological detection together. And one advantage of that is that we do have a system that can handle that. And I'm going to talk a little bit more about that, as well as slides a little bit later in the next section of how that actually works. But with one of the things that the BioWatch program, I think, taught us in particular is we have, and we've spent areas of being able to determine, technologies which allow us to identify. The problem becomes, when do I take a sample and when do I know I need to take a sample? So one advantage is of how this the Proengin technology can be used as a holistic response is just the fact that it is really good for sitting there running multiple hours, 24/7, being able to identify, hey, something weird is happening. There's a high area of biological activity, and then take a sample of that and then process that to those other technologies that can use you to identify for it. The upfront screening and the upfront ability to handle these in a holistic thing. An additional challenge that we also saw is how do you handle, we had a couple customers that had come to us and just how do you handle a variety of different technologies all put together. So Proengin does not make radiation detectors, but you need to integrate those as part of a holistic CBRN response. And so that was really one of the reasons behind Proengin SHIELD, is being able to monitor multiple detectors at a facility, customers wanting to select and put in systems on their own autonomy, so not letting us know exactly where they're putting them, but wanting tools that allow them to monitor multiple detectors, including multiple detectors that aren't even made by Proengin, together into a thing. And that was really the predecessor of why Proengin SHIELD was created as part of a holistic response. Next slide, please. So what we see here is just the AP4C VB. So the VB is a relatively new product, especially our Gen 2 system. In addition to that, what we have recently integrated it with is through external triggering systems, being able to take into our sampling systems to actually create a sample. So in many cases, these materials are being utilized in either facilities where they're monitoring it from one location and they're far away from that. And if you are dealing with, especially really with chemical and biological materials, that especially for these purposeful releases, there's only going to be a certain amount of time where those are going to become in contact with it. And if you have to get someone suited up and bring them to the area to create a sample, in many cases, that area of high concentration might have already been gone with that. So that's why the biological samplers in particular are helpful, because you can remote trigger those when you get an alarm, and then you have a sample that you can go then and get in order to be able to do that. Additional things with that is you want to tandem or put it in detection with portable detectors, from the standpoint of you have fixed site, they're in known locations, but our adversaries may not always they could know where we're at, but that gives you a point detection. But you also want to bring in other materials to allow that the handhelds are helpful from the standpoint of you're getting that dynamic information as you're going on to be able to see what there is, and also understand the level of concentration that detector is telling you from a chemical standpoint, being able to get that real-time information as you're getting closer to it, knowing how high the concentration is. Maybe the detector, the fixed site detector, is in a location that is actually seeing a lower concentration, and as you're going to get that, you're actually going through an area of higher concentration. Those portable detectors allow you to see that and get that information into the system where someone can understand with that. Because you need to understand, from a standpoint of once there is a release, there needs to be a response. And do I need to just evacuate a small area? Do I need to evacuate a whole floor in my building? Do I need to evacuate the whole building? Do I need to evacuate multiple blocks? All that information is dependent upon the nature of the release and the nature of the threat and how it's morphing over time. And these things are not static, as you know. We have air movement and clouds and plumes, and everything's move. And so it's a constantly dynamic environment. And so decision makers, when they come on site, or the people that are on the security apparatus that are making these decisions, they need to be cognizant of getting that real-time information and then making decisions based upon the information those instruments are telling you, and in the holistic part of just trying to protect as many people as possible as part of the threat. Next slide, please. So what you see here is an example of Proengin SHIELD. It's just on a simple thing, but what you have is in the center of it is a display unit that's displaying information from multiple detectors simultaneously. So on the wall, we actually have both chemical, biological, and radiological and sampling systems all integrated into there. So on the right, we have a AP4CV from the chemical standpoint. We also have a couple multi-gas meters that you see in the bottom right. In addition to that, we have a radiation monitor. We have a sampling system to the left, and then we have our AP4, our biological systems. All of those can be integrated together in a whole. You can have one central location where all those are presented. You can also have wireless communication to them or fixed site communication to them. You can also have that as a computer based if you don't want to display. What the system was really set up was just to give users as much flexibility on how they want to handle it. But the important thing is it allows them to manage and look for alerts and then get that information from them. And they can set up their facility however they want. We don't even have to know about it. We're just giving you the tools to set that up, and you can set that up as kind of however you want it. Next slide, please. So what we're going to see here is a video kind of just showing Proengin SHIELD in action. So if you want to press the start button there, what you're going to see here are there's actually multiple locations throughout there with there. So what you're seeing here is a list of all the detectors. There's multiple detectors at each one of the 5 locations throughout. So we have a different variety of solutions there with it. So we have some our fixed site detectors, so our AP4CF. We have our AP4CV and VB. So actually you're seeing here is the first alert from there, and you're able to activate that. So there's an alert that's coming on. It's showing you exactly which location the alert is. And now you're seeing that threat propagate from there. And you're getting a hit on sulfur on this. You're getting a hit on sulfur on both of those detectors with there. And then you're going to see it propagate out further where we have one of our fixed site detectors, and that's going to start to trigger as well on there. So you're getting alarms real time. You're able to see those alarms quickly, and you can actually access the information, see what detectors are there, and see what the threat is associated with those. Now we're going to do a scenario where it's radio. So that was a chemical release. We're going to do one that's a radiological release. So same thing, the alert pops up. You're able to access the instruments at that specific location, and you can see the data coming from that real time of what that's actually telling us. So now we're going to do another scenario just to show you kind of how it would be utilized with it, where we're going to actually do a bio. So in the case of the biological, what you're going to see is over time, that concentration of the bio index, which I'll go through in more detail in just a couple of slides, is going to start to increase, and it's going to get to a point where that detector starts to actually alarm because it goes above the threshold of the biological. So with biological materials in particular, you wanted to make sure that you see the threat over time, and you can set the threshold on kind of how you want, but again, we'll talk about there a little bit further. But if you see in this location, it's sitting there. So this one is a simultaneous chem and biological. So you see the chemical that's going, no threats with that. Biological index is increasing over time, as would be indicated with a plume. And then you're going to see eventually an alert that's going to come on there. And then you have the ability to process a sample directly on there. So what you're seeing here is you turn on through a relay the sampling system, and that sampling system is now taking a sample of that can be retrieved later on there. And you can see the sample directly on the high level. We also have a list here where you can go into each of their detectors throughout your ecosphere, just check on them, know what their monitoring is, and then you can actually get analytics off of it as well. So let's say you actually had a release and you want to see what's happened over time. So you can see here, these are all your activity things. You can down select to the specific channel you want to see. In this case, we're looking at the hydrogen-nitrogen channel. So this could be a theoretical release of a fentanyl of a material that will trigger on that channel. And then you can see the results and the concentration you got, as well as the time period, how long that was on, the duration of it, and the magnitude of those. So it allows you to achieve those or to go back or to get a little bit of additional information, especially once you've identified what that is specifically. And then you can use this to help you do that. So overall,
Scott, from my perspective, I'm going to jump in for a second.
Yes.
This gives you the timing as you're getting these real-time alerts in your command center or in your command post, depending upon whether you're field or fixed. The one thing that it tells me is, when do I look at my cameras? What can I do if I have my cameras timed to this, where I can actually go back and say, did something happen that I can identify and go back from there? Thanks.
Yeah, a good point. And we can integrate cameras into that as well. So you can, pull those up and see what it is. That's also helpful if you're wanting to understand, if there's people that have gotten, seeing these things, you can see where they are. A bunch of people passed out, or they kind of covering themselves because they know something's going on. There could be a smell associated with them. In that case, they can hopefully respond appropriately. What's scary is the ones that don't have smell, and you don't even know it until it's too late. But additional cameras are obviously very helpful for understanding and getting that real-time situational awareness as well. Next slide, please. So again, kind of like a high level on what some of the software solutions you can see here. So this is an example of a screen capture that you can get off of there. So looking at a specific device. So this is a AP4CVB. So we kind of have 4 quadrants of information. So the specific information on the actual device, the device name, location. Then we have sensor status. So it'll let you know if there is a problem with the detector. In this case, you can see where the cylinders are and their status of it. And then the bottom part is really kind of the most helpful information there. It's giving you a real-time information on the bioindex, what the concentration is, what the trend level is, as well as each of the chemical channels. So you're getting the real-time information as far as the concentration data. You can also do dosage and set threshold levels on there. So it gives you a wide variety of tools on it. And then again, the same thing that we kind of showed below on the video, you can actually access the data on the device. You can see what that time series of it. So in the channel below, you kind of see a simultaneous release of phosphorus and sulfur, and you're getting those concentration levels real time, and you can see the duration and the magnitude and kind of the behavior of the response at that. So obviously, the more information you can get on one of these tools, knowing concentration, duration, magnitude, is also very helpful for understanding how to respond and the nature of the threat that you're seeing there. Next slide, please. So now, again, going to this whole concept of how we utilize these tools in a building type scenario with it. So what the Proengin SHIELD is able to do is to pull disparate variety of different detectors located strategically throughout the facility. So one of the things that we have learned, because it has been done in real world applications, is that your HVAC system in particular is a very good place because it's distributing air throughout the facility. So if you can introduce a agent into that, or a material that you're wanting to do that, the HVAC system does a very good job of distributing that throughout the facility. So therefore, that becomes a critical node on that we want to be able to monitor in particular and to make decisions on that. And usually with a government facility, especially if it's a key important one, those systems can have a collective protection system on there, so they can shut off the external air and move towards a monitored solution and a filtered solution. And we'll talk a little bit more about that in the next couple slides on that. But what you can have is a series of sensors throughout the structure. So your key points, one are the air filtration system or the air conditioning system, as well as your entrances to the facility. So you want to try to always bring people into main facilities, and you can monitor on there. So that would be a great location for example, a radiation monitor, potentially a chemical monitor in those locations as well when your people are coming inside the facility. And so again, one of the challenges is, how do I take these different detection systems, different technologies, different locations, bring all that data together, so then I can use a holistic approach for having someone that's on the security team or your protection team be able to monitor those real time. That can be at an external location hundreds of miles away, or it could be right on the facility. It just depends on how the customer wants to do that and how they're handling that system. And then obviously, once you get an alert, you also want the ability to control different mechanisms, such as putting the system, changing the dampers, putting it onto a collective protection system, locking down the building, or unlocking it for certain locations, or pushing people to one direction and not through others, as well as creating some samples for additional later analysis on there. So next slide.
So I was lucky. I got a chance to sit with Jean-Philippe, who is the mastermind behind this Proengin SHIELD, for several different days recently, and looking at the way that this system could be put in place for some of the critical infrastructure that we in the United States are looking at. And with that said, there's a lot of different pieces that have to come into this. And part of that was, how do you get that decision support to work for you, in support of you, for what's going to give us the best case scenario for the most number of people. And so the first step was trying to figure out, like Scott said, where is the best place for us to place some of these sensors. And so trying to figure out where to put this in any type of building versus a transportation hub. Each one of them has very different flow dynamics. And so we've got to figure out where is that one point where we have the best chance at getting materials. But we also have to take into account that oftentimes that same place is the place that has the highest amount of background material, the highest amount of moisture and humidity temperature flows that are changing dramatically. And so this is why I've been looking at this specific solution. But in here, trying to figure out in a building, it's pre-filtration, trying to get ahead of that turbulent flow. And so knowing that if we can get before those filters where it starts to destabilize the flow, we can get our highest chance at success of getting that material within the building. Okay, and so what we then need to do is figure out, how do we seamlessly get that to work with the building management system, knowing that there are disparate building management systems for each building we work with. And in many cases, some of the buildings that I work with, there's disparate building management systems within the building. And so we have had that issue with several buildings and facilities within defense that are built at different times that allow us to have completely different disparate systems with disparate capabilities. And so what we're looking for here is, what are the areas that we can place things, and that's just the sampling interface, to allow us to get the best case scenario for providing the information we need. So now what do we do with that information? So there's two different types of threats from a fixed facility that we're looking at here. One is there's an external threat, meaning there's a CBRN threat on the outside of the building coming in. What do we need to do then? Because that's going to be very different of an internal threat released within the building that we don't want to spread throughout. So from the external threat coming in, where primary goal is trying to keep that plume out. So we need to close those intake dampers, shut down the return fans. If we can, pressurize the zones and prevent entry in that way. So we've talked about this over and over. How do we shut down those dampers and things? Years ago, it had to be manually, but by integrating directly with the building management system, in most cases, we can turn on those dampers and close them efficiently from a remote location. The other thing we can do is sometimes there are fans and things that we can use that will allow us to provide a positive pressure outwards to make sure that we don't have that passive internal threat. If we go into that internal threat protocol where something's been released inside, now we want to make sure that we can negative pressurize that one space and minimize the spread of the material throughout the building. It's already in the building, but can we get a safe and effective passageway for people to exit the building while holding as much as possible that threat material in place? So in that case, the intake dampers are actually open or left alone. The return fans are still shut down, but now we're trying to pressurize the zone to a negative pressure. Okay, and our objective is to minimize that spread. This is oftentimes something that we do if we can over-pressurize one special area and put people into that area. So understanding what your building management can do and understanding what are your best cases for survivability with building flow. One of the things that we do with some of our transportation infrastructure is, can we put in an exhaust fan that can exhaust large areas quickly? And if so, can we flip that fan on when something has happened? And if we do that, what's the effect on the outside? And so trying to figure out all these things, but it's trying to make sure that that pre-event decision planning is able to be made into a logic flow that allows the system to autonomously do these things for you when something happens. So if you have an event that occurs and the system starts to detect, can it automatically close those dampers to make sure that it doesn't get worse while you send somebody to that point with protective gear to then further investigate? And so what are the things that we can do to make this more survivable for the most? So as we start looking at this, we're trying to eliminate the blind spots in the building and with the detection sources. One of the things that greatly does is strengthening our biological defense posture. Maximizing the impact of the existing detection technologies by not requiring all detectors to be from the same manufacturer, allowing disparate sources, but understanding those sources and making sure that the data comes across to minimize your false alarms at the same time. That's going to be critical. So escalating it across all the levels, whether you're seeing this at your forward command or right there where you are. Let's say you're in building 1 of a 10 building series. Building 1 can see it, but so can't building 2 through 10, as well as your national manager. Okay, so making sure that everybody has access to that information when it makes sense and reducing that stress of making decisions, because now you can have people who are outside of the event being able to help. So connecting all your detection, your validation, and your decision making across all the flows. So you have all of your sensors and your strategic command all linked together. So the goal here is detecting things earlier, detecting them faster, detecting them sooner. So deciding sooner. So it's all about being able to get that detect to decide in a very quick time frame. Now, we've said a couple of times this bio trigger. And instead of going into those full-scale bio detection systems. And there's a reason that I am very much looking towards the bio trigger systems. And with that said, the reasoning behind it is for most of the biological threat detection systems that we use in the operational world today, they can't tell us, even if they uniquely identify something, they can't tell us whether the threat was viable or not. We still have to collect the sample, bring it back to the laboratory, and culture it to make sure that it's a viable threat. Because remember, even if we're doing polymerase chain reaction at the very end for unique identification of a biological threat, it can uniquely identify it, but in step number 1 of its amplification process, it destroys that threat. So we never know whether that threat was actually viable or not, because it was destroyed in step 1. So whether it was destroyed beforehand or not doesn't matter, doesn't play a role. So we have to take the threat back. So with doing that, one of the reasons that we've been looking at trigger systems are, it just tells us, instead of continuously taking samples and spending a lot of time and money of collecting samples that may not have had any trigger to say, something is different. Why are we taking a sample? So these trigger systems, what they do is tell us that following their real-time monitoring, their adaptive baseline characterization, they can tell us if something is a true anomaly. And so if we have a true anomaly that doesn't make sense, now take a sample. And by doing that, having it within an automated system like SHIELD allows you to then activate the collector. And so if you have something like this SAS collector here, it allows you to grab that sample and then hold it. Now we have that physical sample that can be used for both evidence collection, but it also can be used to culture that media in the lab. Now, tier 3 is where somebody does collect the sample and bring it to the lab still. Unfortunately, with today's technologies and everything that we have in the works right now, we still will always have to culture a biological sample, because the way that we amplify the samples is destroying it to begin with. So we must take it to the lab and culture it. So by doing a trigger-based system, it does allow us to conserve those resources. So we're not just randomly taking samples and hoping to catch something when it occurs. But it also gives us that instant heads up of something just happened, which is an anomaly. In using an adaptive real-time background monitoring, and by adaptive, what I'm saying is this background monitoring is learning as it goes. It's recognizing when we have different time profiles where there may be, let's say, a big flux of people coming in and out at different work event times. That gives us a background of pollen that we should be recognizing. But looking at anomalies outside of the norm and saying, collect a sample now, and that collection will allow us to take it, grow it, as well as use it for evidence. And then all of that while still managing all the data as it comes through. So a pretty cool approach to being able to get a real biological capability without costing us everything we've got. So Scott, I'm going to send it back over to you.
Yep. Thank you. So again, giving you a little bit of background on how the technology actually works. So we have had previous webinars where we've gone into this into a deep dive. So I'm going to hit it more on the surface, but it is important, especially on the biological side, because some people may not be aware of how flame spectroscopy works and how it can be utilized as part of a holistic response and how it can do biological in particular. So we have some dedicated ones that go into that a lot more detail. So please go to those for the full background. But the elevator speech on this, in this case, is from the chemical side, or how the technology works, is that we provide an energy source to the incoming airstream. And what happens is the airstream is excited. And what happens when the atoms are excited? They go to excited state. And when they go back to their ground state after they're through the energy source, they release certain elements, release a compound specific to that element and that element only. And so what we do is we capture that spectral information and we look for the specific fingerprint of those elements that we're looking for. And the concentration of the materials in the airstream is directly a linear relationship to concentration. So the more energy that's present, the more spectral energy that's present, the more atoms that are present in the airstream. So what we're looking for on the chemical side are 5 basic channels. So 4 of those are primarily your CWA or your toxic industrial chemicals or materials that contain that. So that's phosphorus, sulfur, arsenic, and hydrogen nitrogen bonds associated with that. We can also do a hydrocarbon channel, letting you know there's a flammable environment on there. On the biological side, what we're looking for is sodium, potassium, and calcium for there. So in particular, the biomaterials that we're looking for, sodium, potassium, and calcium, we've exposed hundreds of different samples of different types of biological materials and biological surrogates, and there's specific ratios between sodium, potassium, and calcium, and ranges of associations of those for each of those types or classes of materials, whether a virus or a biological or a sporulated material associated with that. So those areas or those distributions allow us to look for this. So you can kind of take like a 3-dimensional space where we know the distribution of those different types or classes of materials, and we're looking for that. One of the challenges, and the reason why we have a new version of the detector, the Gen 2 detector with improved algorithms, is in particular, one of the materials we look for is sodium. One of the things is you can put a detector near the ocean, and the level of sodium in the ambient air is going to be higher. So what we had developed with the new generation is we first sit there for around 15 minutes, and then we determine what the average biological activity is in the background, and then we use machine learning algorithms thereafter looking for those distributions. So those responses are still the same, but we're now taking into machine learning, and then we're applying probability to that in order to do that, to do the triggering alarm. So the resultant of that is a better performing algorithm as far as our trigger ability. And so we've recently done testing where we released a variety of different biological surrogates, and we were able to alarm with that within the time frame that we wanted. And we also, an additional advantage of that, especially on biologicals, a lot of times you have surrogate materials in there or interference, what we call interference, which are just materials that can exist naturally in nature, or they can actually be purposefully released to by an adversary to trick or to falsely trigger or to confuse detectors. And so a lot of those materials are diesel fumes, silica, I forget a couple of other, I should remember that. I just got a brain hiccup with that. But we released those different interference, and we did not trigger from those. So that's actually a good sign as well. And kind of the next slide will kind of go to that in a little bit more detail of this. So this is just a hypothetical release associated with that. So you want to click it, and it'll kind of run it through there. So what you're seeing is the background noise of the system that exists naturally. So once we've seen there and learned, what we're actually doing is, in the case of this, is there's actually a purposeful release that occurred over a small period of time. And so because we learned, we can differentiate between the background environment and the actual release. We're able to identify and then flag off of that when we want in there. So that's what one of the key aspects of what's important about this new algorithm is. It allows us to differentiate there. And biological protection in particular is a challenge, because us humans are very good incubators and dispensers and holders and transmitters of biological materials, which is different than what you will see on your chemical threats. So a lot of times with your chemical threats, you're looking for something that's normally not there. And so therefore you can say, hey, this is not. In the case of biologicals, they're all really there to a certain degree, depending upon the time of year. So in the summer, tends to be more biological in the ambient than it's in the middle of winter when it's dry and cold. But the challenges of that are, your facility has to operate in the cold and the warm in different parts of the year. And so that's also a challenge with it. And so the algorithm allows us to understand the environment and adjust accordingly with us, so we would limit the false triggering of the device as well. So next slide. So again, as far as The overall approach to this is having a simultaneous chem and biologicals important because we can handle a large amount more of material. It's in a single machine, so you don't have to have two separate detectors with different solutions or other things with that. And then you still need to attach it to other things as part of a holistic response. So I kind of like to talk about this as kind of one of those examples where 1 + 1 = 3, where if you just had individual detectors, they help. But if you can link them together and share the data amongst the things, therefore it becomes a much more actionable data for you with that, because you want both correlation, but also understanding how the relationship of those materials do, because in many cases, more than one detector can be telling you similar things. And so you want that correlation of materials associated with that. And you also want to use that for decision-making, because that decision-making is important. So both speed of response and knowledgeable about response and making sure that you're protecting your first responders as appropriately and providing them with this much information, as well as the people in the back office that are operating, or really the brains to a certain degree behind that, because they aren't quite as stressed of an environment, but they have access to other tools to help guide and direct that overall approach. So the overall integration of all these technologies becomes very important as part of this response. Next slide, please. So what we're going to do, next slide, is just kind of give you now for critical infrastructure. So we kind of talked about public buildings in critical infrastructure, kind of the same threat methodologies with this. You're wanting, again, HVAC system, the intake in particular. That's where it's a smart place for, if you're an adversary, you're wanting to do that, so to release those and put those into the system, as well as your key choke points throughout your facility. So if you have a place where people are lingering for long periods of time, for example, a security line through the airport, those choke points are attractive for adversaries that want to release something, because their job or what they're trying to do is attack as many people as possible. So you want people to attack people where they're going to be standing for longer periods of time, so allows it to have the effect. You also probably want to do that ahead of security, so more public spaces versus more that are past security places, or those choke points, because of both just the number of people as well as their slow proximity, so allowing that to work better. So you're wanting some of these key technology points to strategically put them throughout the facility for where the threat environment is as high, as well as the location of where there's most people, and then holistically put that data together as part of a holistic response. Next slide. So just a follow-on thing. So we do have a couple upcoming webinars with this. So the next one will be on September 9th, where we're going to be talking about drone mounted operations. So I know that drones in particular are getting a lot of attention, as well as for detection standpoint. So we're going to be covering that, both UAVs and UGVs and applications of attaching detectors and how to use those with us. And then in December 9th will be our fourth one. We're going to look at orthogonal detection, so combining of multiple technologies together for decision makers and to correlate different things with that. So I hope.
And one of the things, Scott, that I think is so important here is that we can integrate any of our UAV-based systems and UGV systems right through SHIELD as well. And so it doesn't have to be a separate system. Those things that are on the move can also be incorporated. And then the technology integration with the orthogonal detection is, how do we take all of that data and make sense of it? How do we take things that may be providing similar data sets and say, what can that do for me in terms of ruling out those false positives and starting to get down on all of those nuisance alarms? And so with that, I guess the thing that we're really trying to put forward today was that it's really not just detecting the threats. We can detect the threats. The problem is we have to detect them low enough at where they're operationally relevant. We need to detect them fast enough, okay? And we need to be able to do something about it. So what's the decision we're going to make with that data? And so what we've been trying to work here with is trying to make sure there's a way to compress that time between when you detect it and when you can actually act upon it. And so that was the whole point of this today, was to try to get through that process of where are we focusing efforts to make sure everybody's on the same page about protecting critical infrastructure, whether it is a fixed facility where you're talking about one facility with multiple detectors within it, or if you're talking about an area where you may have multiple detectors in external locations where you're trying to say something has happened in this borough, okay, and going from there. So hopefully we covered both of those for you. I'm going to see if we had any questions show up in the questions box. I don't see any questions in the question box, and let me see the chat. So nothing in there. So with that said, Scott, do you have any parting words for everybody?
Yeah, one thing I failed to mention that just for the that I think might be helpful is in case of some of the biological toxins, one advantage of having the simultaneous chemical and biological is those toxins in some cases will not behave as biologicals, but will behave as chemicals. So having those materials will be helpful. So for example, the U.S. is kind of the ricin capital of the world. But one of the things that ricin has is a disulfide bond. So we will actually be able to see that on the sulfur channel, depending on the nature of how those are released and how refined they are. But those materials would be done in a lot of those toxins that Christina had mentioned on there. They do have many cases hydrogen and nitrogen bonds that we will see. So your tetrodotoxin, your caffeine, your nicotine, pure materials like that. Most likely they'd be released as aerosols, but they would be, they're biological derived materials, and they can biologically affect us, but they would be handled as chemicals, and we would see them on some of the chemical channels.
Thanks, Scott. And I just want to remind everybody that we did see all those changes with both Inspire Guide coming out again in March of this year, and Invade magazine, the new magazine coming out. And remember, the focus is on aerosolized threats. Okay, so your filters are going to block you from seeing those. And that's from the chemical side. They're looking at aerosols. Biological is almost always aerosols anyway. From a biological threat, a lot of the new materials are modified, which means we won't see it in library-based systems. And we have to be really careful about that level that we can identify to take a sample. And so as we go forward, we want to make sure people are paying attention to areas where people are congregating, where lines are forming, where there's choke points, and start putting a better protection into those locations and start figuring out where you go from there. With that said, if you have any further questions, Scott and I are both always available to you via our cell phones, which are on the screen, as well as our email addresses. So please feel free to reach out, and we will do whatever we can to find the answer to get back with you. And please also remember that, there's a whole group that works on pulling all this information together with us for these webinars. So thank you to Naomi and Jean-Philippe and a few others that were helping us get all of this information pulled together. So thank you. Stay safe out there, and we will have this up for you in a few days. Thanks.
Thanks.